We are going to go over this Unit 1 study guide, so kind of bear with me. I'm going to go relatively fast because I don't want to make a super long video. So feel free to stop at any point, rewind, or fast forward if you already feel comfortable with this material. But this is just basically a general video going over the review and how we get there. Okay, so first section we're going to start off with is just write the number of significant figures that are in each of these correctly taken measurements. So we're just counting significant figures. Okay, so when we count significant figures, remember our rules. Okay, so when it comes to trailing zeros, like number 1, trailing zeros only count if there's a decimal. So if there is no decimal there, those trailing zeros do not count. So this 2, let me get my pen. 2 and 3 count, but these trailing zeros do not count because there's not a decimal. So this would just have 2 significant figures. On number 2, remember any zeros that are sandwiched in between will always count. So 1, 2, 3, 4, 5. That one has 5 significant figures. Let's look at the next one. So remember, zeros in between any non-zero numbers are going to count. So 1, 2, 3, 4, 5, 6, 7. So this one has 7 significant figures. Number 4, same rule. Zeros in between count. 1, 2, 3, 4. 4 significant figures. All right, leading zeros do not ever count. Okay, even if there is a decimal, these zeros do not count. So that means only 4, 3, and 8 are going to count. So that means I have 3 significant figures. Number 6, 1, 2, 3, 4, 5. I have 5. Okay. Our numbers are shifted up a little bit on here, so don't worry about it. So leading zeros never count. So nope. 2 and 3 definitely going to count. And since there is a decimal, that trailing zero is going to count. So this one has 3 significant figures. Number 17, there's a decimal there. So all these trailing zeros are going to count. So 1, 2, 3, 4, 4 significant figures. Leading zeros never count. So I'm going to go ahead and put little X's under them, and 1, 2, and since there's a decimal, these zeros are going to count. So this is 4 significant figures. I see a decimal. So 1, 2, 3, 4, 5. 5 significant figures. 450, I do not see a decimal, so that 0 is not going to count. So 1, 2, only 2 significant figures. 32,000, no decimal, so these zeros are not going to count. So 1, 2, and then I am done with that. So just remember to take a look over those significant figure rules if you're having trouble on that. And then next we're going to go into rounding. Okay, so rounding. When it comes to rounding, we're going to tell you how many significant figures to round to, and then it's your job to count to that and then determine where you stop and how we round. So first one, it wants me to round this number here, 6.13159, to 5 significant figures. So I'm going to count from the left, 1, 2, 3, 4, 5, and I would draw my line right between that 5 and 9. And that 9 is going to tell me that I'm going to round that 6 up. So my answer would be 6.1316. And that's it. So if I wanted to round to 4 significant figures, I'm going to start from the left. 1, 2, 3, 4. Draw my line. This 5 is going to tell me that I'm going to round that 1 up. So my answer would be 6.132. Then it asks for 3 significant figures. So let's do the 3. So I'm going to count from the left. 1, 2, 3. Draw my line. That 1 is going to tell me that I am not going to round up. So remember, 5 and up, you're going to round up. 4 and down, you stay the same. So my answer would just be 6.13. Next one, I only need 2. So I would count 1, 2. Draw my line. This 3 would tell me I'm not rounding up, so my answer would just be 6.1. Okay, let's do the next one. 5 significant figures, so 1, 2, 3, 4, 5, draw my line. 0 is going to mean I'm not rounding up, so my answer is 7.5953. Next one is 4 significant figures. 1, 2, 3, 4, draw my line. 3 is telling me that I'm not going to round up, so my answer is 7.595. Okay, so we know the next question is asking 3 significant figures. So I'm going to count from the left. 1, 2, 3. This 5 is going to tell me that I round that 9 up. When I round that 9 up, it becomes 0, but that also adds another one to that 5. So 59 is going to round to 60. So my answer would be 7.60. Okay, so this 0 right here counts because there's a decimal. So that is 3 significant figures. And then our last one is just doing 2. So count 1, 2, draw my line. That 9 is going to tell me that 5 is going to round up to 6. So my answer would just be 7.6. Okay, so that is rounding. So take a look at rounding rules if you need a refresher on that, if that confused you any. Okay, so let's go on to the next one. We're writing scientific notation. Okay, so remember, this is standard notation, like a number that you would standardly see anywhere in your life. Okay, when we go in scientific, it's for us to condense it or abbreviate it. So, first one, we have 5,800. So we always start from where the decimal would be. So if there was a decimal, it would be right here. And you're going to go to the left until you get to a number between 1 and 10. If you went to the right, your number would just get bigger. Okay, so we're trying to make it smaller. So we go to the left, 1, 2, 3. So 5.8 is a number between 1 and 10. So my answer would be 5.8 times 10 to the however many we went to the left. So we went over 1, 2, 3. So my power would be a positive 3. Okay, so when we're dealing with big numbers, you have a positive exponent. Okay, we're dealing with small numbers, which we'll go over here in a second, you deal with a negative exponent. So do not forget that. Also, do not forget, if I give you units, your answer needs to have units. So don't get points taken off for something as simple as that. Letter B, start from the decimal as that. So we're going to go to the left. 1, 2, 3, 4. Oops. I don't know what happened there. Let's try that again. 1, 2, 3, 4, 5. So that gives me 4.5 times 10 to the 5th meters. Okay, so another quick thing to touch base on is your significant figures. However many you start with, better be how many you end with. So back in letter A, I had 1, 2, only 2 significant figures. Those zeros did not count because I did not have a decimal. I know I started from an imaginary point, but that decimal was not given. So my answer better have 1, 2. So 1, 2, so that is correct. Letter B has 1, 2 significant figures, so my answer has 1, 2, 2 significant figures. So whatever you start with better be what you end with. So let's just do that first in the next one. So 302 million has 1, 2, 3 significant figures. Those zeros do not count because there is no decimal. So my answer can only have 3 significant figures. So I'm going to start where the decimal would be and go 1, 2, 3, 4, 5, 6, 7. Did it again. Okay, so let's try it. 1, 2, 3, 4, 5, 6, 7, 8. So 3.02 times 10 to the 8th meters. I have 1, 2, 3 significant figures, so they match. D, start with the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8.61 times 10 to the 10th power in meters. I had 1, 2, 3 significant figures, so I have 1, 2, 3, and so that number is good. Now let's go to our small numbers. Okay, so remember, leading zeros never count, and we always go to the number between 1 and 10. So the trick for small number is as soon as you get past that first non-zero number, you stop. Okay, so we're going to start from where the decimal is. We're going to go over 1, 2, 3, 4. So I just stopped right after that first non-zero because 5.08 is between 1 and 10. Now I'm going to times 10 and however many I went over to the right. So I went over 1, 2, 3, 4. So my power would actually be a negative 4. So remember, if you're doing a small number, your power is negative. And don't forget your units. So I had 1, 2, 3 significant figures. I have 1, 2, 3 and my answer is good. So start from the decimal. 1, 2, 3, 4, 5, 6, 7. So 4.50. I'm going to keep that 0 because that 0 was significant when I started. Okay, so 4.50, because there's a decimal there, that trailing 0 is significant. So 4.50 times 10 to however many I went over by. So 1, 2, 3, 4, 5, 6, 7. So that'd be a negative 7 kilograms. Next one, start from the decimal. 1, 2, 3, 4. Okay, so 3.600. Those zeros were significant because there was a decimal, so I have to keep in my answer. So 3.600 times 10 to the 1, 2, 3, 4. So negative 4 power kilograms. Next one, 1, 2, 3. So this is just simply 4 times 10 to the negative 3 kilograms. That is scientific notation. Okay, so now in the next section, we're going to do a quick section of how to go back to standard. Okay, so first of all is I'm going to count my significant figures. So I have 1, 2, 3, 4, 5, 6. I have 6 significant figures, so my number better have 6. And I have a positive exponent, so it means it's going to be a big number. So my decimal has to go to the right. 1, 2, 3, 4, 5. So 580,100. Now, if I left it like that, I would get part of this wrong, because if I count my significant figures, I only have 1, 2, 3, 4, but I started with 6. So I need 2 more. So if I put a decimal here right at the end of that 0, these zeros now become significant. So that would be my answer. So do not forget to put a decimal there if you need to make 0 significant. So 8.12, I'm going to write it over here to give myself a little room because I know it's going to be a big number. So I'm going to go to the right by 7. 1, 2, 3, 4, 5, 6, 7. So now I'm going to fill in my baskets. 1, 2, 3, 4, 5. So I got an answer of 81,200,000. And I started with 1, 2, 3, 3 significant figures. I have 1, 2, 3. So I do not need to add a decimal anywhere. And then that is in meters. Okay. Letter C, I have 5.0 times 10 to the negative 2. So I have 1, 2, 2 significant figures. And a power of negative 2. So that means it's a small number. So the decimal is going to go to the left. So we're going to go over 1, 2. Decimal is here now. So 0.050 is going to be my answer. So 0.050. So I kept that 0 in there because it was significant to start with. Kilograms. Last one. So negative 3. So we have a small number. So our decimal is going to go to the left. So 1, 2, 3. Fill in my holes. So 0.002110 meters. Okay, so I had 1, 2, 3, 4 significant figures to start with. I have 1, 2, 3, 4 to end with. So I am done. Okay, so that was going from scientific to standard. Okay, so this next section, I'm going to try to fit it in as best as I can for adding, subtracting, multiplying, dividing. Okay, so when I think of adding and subtracting, I think of old school elementary. Okay, so I like to stack. So I'm going to put 258.3 plus 250. Oops, let me fix that real quick. Oh, that just pretty much erased everything. So let me start over. So 258.3 plus 257.11. And then I have 253. Okay, so this stack method only works if you make sure your decimals are lined up. Okay, if they are not lined up, this will not work. Now, when it comes to adding and subtracting, you're only as good as your weakest link, so our least accurate number. So if I look at 257.11, I go all the way to the hundredths place. Okay, so that is a pretty accurate number. or pretty, I guess, in-depth number. 258.3 goes to the tenths place, so that's still pretty accurate, not as in-depth as 257.11. And if I look at 253, that one is not even into the decimal place. Okay, so that is where I have to stop. So I have to draw a line right here where my decimal would be. Okay, so now I just simply do my math. So bring down the 1, and this is 4. 18, carry the 1. 16, carry the 1, so 768.41. Okay, so that line tells me where I have to stop. Okay, so now that 4 is going to tell me that that 8 is not going to round up. So my answer would just be 768 kilograms. Okay, multiplying, dividing, we have to count significant figures. Okay, so for 13.65 has 4. 23.20 has 4. 42.0 has 3. So remember, you're only as good as your weakest link. So here, my answer can only be as good as my least amount of significant figures. So that means 3 significant figures is how many I can have in my answer. Okay. So then you just go to your calculator and we're going to do our math. So 13.65 times 23.20 times 42.0. That gives me the number 13,300.56. Now, I can only have 3 significant figures, so I'm going to start from the left. 1, 2, 3. Draw my line. This 0 is going to tell me that 3 is not going to round up. So my answer would be 13,300. Do not write 133, okay? Because 13,300 does not round to 133. These zeros can still be here to serve as a placeholder because you're still doing the big number. And since there is no decimal, they are not significant. Okay. Now let's look at our units. So when you multiply and divide units, we have to add exponents. So when you look up here at centimeters, you got to pretend there's a little imaginary 1 above each centimeter. Okay. So this is different if it was like centimeters squared, centimeters cubed, because you'd be able to see the exponent. When you don't see anything, there's like an imaginary 1 there. So I'm going to do is 1 plus 1 plus 1. So this would actually be centimeters cubed. Okay. Letter C, 120 times 0.010 meters. Okay, so multiplication, count my sig figs. So 1, 2, 3. 1, 2. So my answer can only have 2. Okay, so now I'm just going to do my math. So 120 times 0.10 gives me 12. So that has 2 significant figures, so I don't have to do anything else. I don't have to do any rounding. And I did multiplication, so when you multiply something with units, exponents, so that little imaginary 1 there, we add them. So this becomes meters squared. Okay, letter D is we have adding and subtracting. Okay, so we can do this multiple ways. So remember, just the stacking. So 5.46 plus 1.329. Okay, so remember PEMDAS. Okay, so adding comes before subtraction. So that is something we need to do first. Okay, so I'm going to do my adding first. So I'm only as good as my weakest link, so I'm going to start there. So this 9 comes down. 6 plus 2 is 8. 4 plus 3 is 7. 5 plus 1 is 6. Okay, this 9 tells me this 8 is going to round up, so I have 6.79. Now I'm going to subtract 3.12. Okay, let me just fix that real quick. Okay, so remember your PEMDAS. So adding comes before subtraction. So now I'm going to do my subtraction. They're both ending at the hundredths place, so I don't have to worry about that. I don't have to draw a line since they're both ending in the same spot, so that's definitely where the answer is going to be. So 9 minus 2 gives me 7. 7 minus 1 gives me 6. 6 minus 3 gives me 3. So my answer would be 3.67 grams. Okay, letter E. So remember PEMDAS, so parentheses. Okay, so anything in parentheses is going to be done first. So I've got subtraction, so I'm going to do my subtraction first. So 11.35 minus 4.5. Okay, so I'm going to draw my line right here because 4.5 only goes to the tenths place, so that's as far as I can go. So 5 minus 0 is 5. 3 minus 5 don't have enough, so I'm going to borrow. This is going back to old school. 13 minus 5 gives me 8. 0 minus 4 don't have enough, so I'm going to borrow. 10 minus 4 gives me 6. Okay, so you could do a calculator, so I'm just doing this on the screen right here. So this 5 is going to tell me that I will round that up to 6.9. So now I can do 6.9 divided by 2.36. Now we're in division. We have our significant figure rule. You're only as good as your weakest link. 6.9 has 2 significant figures. 2.36 has 3, so my answer can only have 2. So I'm going to go to calculator. 6.9 divided by 2.36. That gives me a big number. So I get 2.9237, and it goes on, but I only need 2, so I'm just going to stop here. So I'm going to count 1, 2, draw my line. This 2 is going to tell me that I'm not going to round up. So my answer would just simply be 2.9. Okay, so again, if I'm going fast, feel free to stop it and rewind it. I'm just trying to get through this in a relatively shorter video. So 93.26 centimeters minus 81.104. Okay, so we're doing subtraction, so I'm going to stack. So 93.26 minus 81.140. Okay, so 93.26 just goes to the hundredths place, so that's where I have to stop. So now I'm going to do my math, so 0, 2, 1, 2, 1. Okay, so this 0 tells me I will not be rounding up. So my answer would just simply be 12.12, and don't forget centimeters. When it's adding and subtracting, don't worry about exponents on units, it's just simply centimeters. Now, letter G, I have 4.84 grams divided by 2.4 milliliters. So we're doing division, so this counts, we're counting significant figures. So 1, 2, 3 has 3 significant figures, 2.4 has 2, so my answer can only have 2. So 4.84 divided by 2.4 gives me 2.0167, and it keeps going on and on. I only need 2 though, so 1, 2, draw my line. So my answer would actually be 2.0, and grams and milliliters are different, so they're not going to cancel out, or we're not going to do anything with exponents since they're different, so it would just simply be grams divided by milliliters. Okay, 60.2 meters, so I have 3 significant figures. 20.1, I have 3 significant figures, so my answer can only have 3. So 60.2 divided by 20.1 gives me 2.9950, and it goes on, but I can only have 3. So 1, 2, 3, draw my line. Now this 5 is going to round that 9 up, which would then round the next 9 up, which would then round the 2 up. So this now becomes, so 2.99 now rounds to 3.00. Now I kept a decimal in here, okay, and I put those zeros in there because they are significant. I need to have 3 in my answer, so now I have 3. And it's meters per second. They're not anywhere near each other, so I can't do anything with exponents, so it's just meters divided by seconds. I have 2.53 centimeters minus 1.4 centimeters, so this is going to be stacking, so 2.53 minus 1.4. 1.4 only goes to the tenths place, so that's where I got to stop. Bring the 3 down. 1, 1. So 1.13. Okay, so I kind of ran out of room here. That 3 is going to tell me that I'm not going to round the 1 up, so my answer would just be 1.1 centimeters. Last one, 8.807 plus 7.91 in parentheses times 5.3. So PEMDAS, parentheses first. So I'm going to do my adding first because it's in parentheses. So 8.807 plus 7.91. Remember, the stacking only works if your decimals are lined up. I'm going to draw my line here because 7.91 stops at the hundredths place, and 8.807 goes all the way to the thousandths. So I have to stop after my weakest link. So now I'm going to do my adding. So 7, 1, 9 plus 8 is 17, carry the 1, and that gives me 16. So 16.717. This 7 is going to tell me that I'm going to round that up. So my parentheses answer is going to be 16.72. Okay, now I can multiply it by 5.3. So now I'm going to do significant figure rules. So 16.72 has 4 significant figures. 5.3 only has 2. So my answer can only have 2. So 16.72 times 5.3 gives me 88.616. Now I can only have 2 significant figures. So 1, 2, draw my line. This 6 is going to tell me that I'm going to round up. So that my answer would be, that was a bad 8. So bear with my bad handwriting. So I would give 89, and that's my answer. Okay, so feel free to rewind if you need to go back over this again. Okay, so number 6 was SI units. I'm briefly going to go over this. So remember, SI units it stands for System International. So this is a way that everybody in the world could be using the same units without getting things constantly confused by having to convert them back and forth. So these are the accepted SI units. Okay, so you will need to know these. Okay, so for length, it would simply be meter. And that is a symbol of M. Mass is kilogram. And that is a symbol of kg. Time, seconds. It's characterized by, I'm sure you can guess, lowercase s. Volume is actually meters cubed. So we're just going to put meters cubed because we don't have to write out meters cubed. Our symbol would be meters cubed. Temperature is Kelvin, which we will go more in depth later on with Kelvin, and it's capitalized by a capital K. And an amount of substance, so the amount of substance in an atom would be mole, and it is a symbol of, all they did was take away an E, so it would just be MOL. Okay, so those are your SI units. So those will be something that you need to know. Now, metric scale. I've already made a video on how to kind of memorize the metric scale. So take time to remember the great mighty King Hector died by drinking chocolate milk under no particular fashion. Okay, so again, you can change the words up if you want to. That's just something that we use. Okay, so what we're going to start off with is we're just going to start off with tera. So tera is going to be abbreviated by T. Power of 10, so remember tera is our biggest one, so 10 to the 12th. And then that number is actually a lot of zeros. Okay, so I think actually the easiest way is to start at base units, because if you can start at base, you can figure out where to go from left or right. So instead of me going all the way down, I'm going to go start from the base units. Okay, so base units does not have an abbreviation because nothing comes before it. Okay, so that's things like your grams, liters, seconds, something without a prefix. Okay, your power of 10 is 10 to the 0. Okay, so that means 10 to the 0 equals 1. So this is where I like to start, is from the base. Then I can go left and right from there. So let's go up from here. So my powers are just going to go up. So 10 to the 1. Okay, and this is deca. So this would be dA, and that number would be 10. So we're adding a 0. So 10 to the 2 is our next power. Okay, that is considered hecto. And abbreviation would be H. And that is 100. So we add another 0. Then we have kilo. Okay. Abbreviation would be K, and this would be a 10 to the 3rd power. So as you can see, we started at base with 10 to the 0, then it goes 10 to the 1, 10 to the 2, 10 to the 3. Then after 3, we jump up by 3s. So 10 to the 6 is next, and that's going to be mega. That's abbreviated by a capital M. That's an awful M. So let me do that again. Not much better, but 10 to the 6th. Okay, so now we added a whole nother 3 zeros. So now instead of 1,000, this is now 1 million. Okay, 10 to the 6th. Now we're going to add another 3. It becomes 10 to the 9th. And that is giga, which I'm sure you've heard about. Okay, so you've gone through all your gigs of data on your phone. This is what it's talking about. 10 to the 9th is going to be even bigger. So that's going to be 1 billion. Okay, so those are my big numbers. So now I'm going to go back to my base, and I'm going to go the other way. Okay, so I'm just going to do the power of 10s, just kind of finish up that. So we know when we went up top, it was 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 6, and so on. It's the same going the other way, but it's negative. 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 6, 10 to the negative 9, and 10 to the negative 12. Oops. 10 to the negative 12. Okay, so we'll start at 10 to the negative 1. This would be deci, and that's characterized by a little d. Okay, and that's 0.1. Centi is next, and this would be 0.00. Oops, sorry. Jumped ahead of myself. So 0.01. So we just added a 0. Then we have milli. This would be a lowercase m. That's 10 to the negative 3. This one would be 0.001. Micro is abbreviation is a little, it's like a weird U with a long nose. Okay, little m was already taken. So we use that character for it, and that's 10 to the negative 6th. And that would be 0.000001. The next one is nano. So that's just a lowercase n. As you can see, we added more zeros, and that's 10 to the negative 9. Then we have pico. That's 10 to the negative 12. So pico would be 0.0000000. Let me just count to make sure I'm right. So we need 11 of them, because now you can see why we do scientific, because this starts to get tedious. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and boom, 1. Next one is going to be femto. That's a lowercase f, and that's 10 to the negative 15. So here we go. We're going to have 14 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 1. Okay, so this is why we write in scientific, because it gets a little tedious counting those zeros, and you can more than likely make a mistake. Okay, so number 8. So we're going to do dimensional analysis next. So part A is convert 3,644 centimeters to meters. Okay, so you can take a look at your dimensional analysis notes if you need to, but I'm going to go over these in just a second. So we have 3,644 centimeters. So first step is draw my line. So 3,644 centimeters. And I am going to meters. Okay, so the way I do this is I always say which one's bigger, meter or centimeter. And I know meters is bigger. So whichever one is the biggest, I just say it equals to 1. So 1 meter. Okay, and meter is a base, so that is 10 to the 0. Centi, that is 10 to the negative 2. So I'm going from meters to centimeters, which means I would go over to the right by 2. So that means I'm going to add 2 zeros. So I would go to the right by 2. 1, 2. And that equals 100 centimeters. Okay, so this only works if you choose the bigger one to equal to 1, and then just simply count how many places you go over to the right to get to the next, to get to wherever you're trying to go, and just add a 0 for each step. Okay, so 1 meter equals 100 centimeters. Now I can go back to my conversion. So centimeters is on top, so centimeters has to be on bottom here for those units to cancel out. That has to be your first thing. So you see how I'm not even putting numbers first, I'm just doing units. Then I'm going to put meters up here because I'm trying to go from centimeters to meters. So I know 100 centimeters equals 1 meter. So 3644 divided by 100 gives me 36.44 meters. Okay, because these centimeters are going to cancel out. And now I'm in meters, so I'm done. So this would be my answer, 36.44 meters. Okay, big thing to remember here is however many significant figures you start with, better be how many you end with. So I had 1, 2, 3, 4. I have 1, 2, 3, 4, so my answer is 36.44. So I don't need to do any rounding at all. B, 74.5 kilometers, so I'm going to start off with what I'm given, 74.5 km. Okay, so I would have to look, which one's bigger, a kilometer or decimeter? Well, kilometer is bigger, so I'm going to say 1 kilometer equals 1. Now I'm going to count how many times I have to go to the right to get to deci. So kilo is 10 to the third power. Deci is 10 to the negative 1. So that means I had to go to the right by 4. 1, 2, 3, 4. So I'm going to fill in my zeros. 1, 2, 3, 4. So there are 10,000 decimeters in 1 kilometer. So now I have my conversion unit, so now I can come back down. So kilometers has to be on bottom next. Okay. Then I'm trying to get to decimeters. So I know 1 kilometer equals 10,000 decimeters. Okay, so one thing I kind of forgot to touch base on is you multiply whatever's on top and divide by whatever's on bottom. So back in A, we did 3,644 times 1 divided by 100. This one, we're going to do 74.5 times 1,000. So 74.5 times, 10,000. And that gives me 745,000. Okay, so let's check our units. So kilometers cancel out. Decimeters is where I'm at, so I'm good. I had 1, 2, 3 significant figures to start with, so I have 1, 2, 3 to end with. So I am done with that. Now I just got to put my units. C, 3.4 kilograms to pounds. Okay, so 3.4 kilograms is what they gave me, so that should be my first step right there. So before I even put any numbers there, on the next step, I'm going to bring kilograms down here because it has to be on bottom next. And we see the conversion factor up here. We will give you these. So 1 kilogram. So 1 kilogram equals 2.2 pounds. Now we simply just do our math. So 3.4 times 2.2 gives me 7.48. Okay, so if I look back where I started, I only had 1, 2 significant figures to start with. So I can only have 1, 2 to end with. That 8 is going to tell me that I round up. So my answer would be 7.5 pounds. Okay, because our units are going to cancel out. Kilograms cancel out. I'm in pounds. So we are done. D, how many inches are in 98.2 centimeters? So 98.2 centimeters. I'm going to bring centimeters down next. And I'm trying to get to inches, so inches is going to be on top. So if I look at my conversion factor up here, 2.54 centimeters equals 1 inch. Okay, my units cancel out, my centimeters cancel out, and then I'm in inches, so I'm done. So now I'm going to take 98.2 divided by 2.54. That gives me 38.6614. It keeps going on and on and on. So let's look back at what we started with. So I had 1, 2, 3 significant figures to start with. So I can only have 1, 2, 3 to end with. That 6 tells me I'm rounding up. So my answer would be 38.7 inches. Okay, Susanna is 5.50 feet tall. What's her height in centimeters? Okay, first thing, 5.50 feet. Always start with what you're given. My next step is feet definitely have to be on bottom, and I'm trying to get to centimeters. They gave me inches to centimeters. They don't have feet to centimeters. So I need to get to inches first. So this is going to be a multi-step. I know 1 foot equals 12 inches. Okay, it wanted centimeters, so I'm not done. So I'm going to draw another line. And I know inches is going to go on bottom next. And now I can go to centimeters. So I know 1 inch equals 2.54 centimeters. So let's look at our units real quick, make sure they cancel out. So feet and feet cancel out, inches and inches cancel out, and now I'm in centimeters, so I am done with that part. Now multiply everything on top. 5.50 times 12 times 2.54 gives me 167.64. Okay, so let's see how many significant figures we can have. I can have 1, 2, 3. So I need 1, 2, 3. Draw my line. That 7 is going to round up. So 168 centimeters. Okay, so how many inches squared are in 150 feet squared? Okay, so you're not going to see too many of these, but I'm going to show you how to do it. So 150 feet squared. Okay, so this is where it kind of can get a little bit confused. So we have feet squared. So we need to have 2 feet on the bottom in order to cancel that out. So I know 1 foot equals 12 inches. That takes care of one of the feet, but I'm going to do 1 foot equals 12 inches. Okay, so again, I know this one is a little bit more confusing. Our big thing is we're trying to cancel out a feet squared, so I need to have 2 feet on bottom. Okay, so now feet squared, so feet and feet cancel out this, and now I'm in an inch times an inch, which will be inches squared. Okay, so which is what it wanted. Okay, so now I just got to do my math. So 150 times 12 times 12 gives me 21,600 inches squared. Okay, so let's check our significant figures. I had 1, 2, only 2 significant figures to start with, so I can only have 1, 2. Draw my line. Okay, so that means that's going to round up. So my correct answer would be 22,000 inches squared. So do not write 22 and be done. Okay, 21,600 does not round to 22. So put those zeros there as a placeholder. Okay, next question. An ant is about 4.0 millimeters long. So start with what they're given, 4.0 millimeters. I know millimeters is going to go on bottom next. How many feet is this? Okay, so I got to get from millimeters. If I look here, I see I have a centimeters to inches, so I need to get from millimeters to centimeters. Okay, so I would look at which one is bigger, a centimeter or a millimeter. So if you look at your metric scale, 1 centimeter is bigger, so 1 centimeter, and I'm going to milli. So milli is just going over to the right by 1. So that means I'm just going to add 1 0. So that means 10 millimeters are in 1 centimeter. So 10 millimeters equals 1 centimeter. Okay. Then I'm going to bring centimeters down here next. And I'm going to go to inches since they gave me centimeters to inches conversion. So I know 2.54 centimeters equals 1 inch. Okay, then it wants in feet. So now I can do inches to feet. So I know 12 inches are in 1 foot. So let's look at our units. Millimeters cancel out, centimeters cancel out, inches cancel out, and now I'm in feet. So I'm done with my units, so I don't need to go any further steps. So now, I'm basically going to do is I'm going to multiply everything on top and divide by whatever's on bottom. So I'm going to do, since 4.0 times 1 times 1 times 1 is 4.0, now I'm just going to divide, so 4.0 divided by 10, then divide that by 2.54, then divide that again by 12. So that gives me 0.01312, and it goes on, but I can only have two significant figures in my answer. So 1, 2, draw my line. That 3 is not going to round up, so that is 0.013 feet. Okay, take a drink real quick. Letter H, how many hectograms are in 7.3 times 10 to the 6 micrograms? So remember, micro is that little weird U. So 7.3 times 10 to the 6th. Okay, so you can do a metric conversion if you want to on this, or you can do dimensional analysis. So I'm going to do dimensional analysis just for the sake of it. So 7.3 times 10 to the 6 micrograms. So I know micrograms is going to go on bottom next. So now I got to figure out is which one's bigger, a hectogram or a microgram? So if you look at metric scale, a hectogram is bigger. So 1 hectogram. Okay, so if I look at hectogram on my metric scale, hecto is 10 to the 2. So hecto is 10 to the 2. And micro is 10 to the negative 6. So that means I had to go to the right by 8 to get to micro. So that means that's how many zeros I'm going to add. So 1, then 1, 2, 3, 4, 5, 6, 7, 8 micrograms. Okay, so let me actually make more room for myself here. So I know 1 and then 8 zeros, 3, 4, 5, 6, 7, 8 micrograms equals 1 hectogram. Okay, so now all we got to do is just do our math. So 7.3 times 10 to the 6th in your calculator, divide that by 1 with 8 zeros. So again, this is why we do scientific, because you have to make sure you're counting all the right zeros. So that gives me 0.073 hectograms. Add 2 significant figures to start with. I have 2 to end with, so I am done. Letter I, 275 meters per second to kilometers per hour. Okay, so 275 meters over 1 second. Okay, so this is a multi-unit. So you have to tame one beast at a time. So you can choose whichever one. Doesn't matter which one you do first. You can do distance or time. We're trying to get to kilometers per hour. So I'm just going to do distance first. So I know meters has to be on bottom next. And I'm going to go to kilometers. Kilo is 10 to the 3rd. Okay, so Kilo is bigger than meter because meter is just a base. So I know 1 kilometer equals, and base is 10 to the 0. So that means I had to go to the right by 3. So I'm going to add 3 zeros. So 1 kilometer equals 1,000 meters. So 1,000 meters equals 1 kilometer. Okay, so let's do our units. So meters are going to cancel out. I'm in kilometers now, and that's just what it wanted. So that means I'm done with my distance conversion. Let's do our time now. So now if I have seconds on bottom to begin with, I know seconds needs to be up top here. And I'm trying to get to 1 hour. Okay, I know personally that 3,600 seconds equals 1 hour. Now you could do 60 seconds equals 1 minute, add another step, and then do 60 minutes equals 1 hour. I just saved myself by saying 60 times 60 is 3,600, so I just saved a step. Okay, so seconds are going to cancel out, and I'm in hours. So kilometers per hour is what it wanted, and that's what I got. So now I'm done with my steps. So 275 times 3,600. Divide that by 1,000. That gives me 990. Okay, so 990 kilometers per hour. Now we got to check our significant figures. I had 1, 2, 3 significant figures to start with. I have 1, 2, only 2. Okay, so there's 2 ways you can do this. You can tell me it is 990 with a decimal kilometers per hour. That would make me have 3. Or I convert it to scientific. So I can come over and go 1, 2, and this would be 9.90 times 10 to the 2 kilometers per hour. And I ran out of room. So both of those could be your answer. So again, just watch out. If we ask for scientific notation, you would have to put that in scientific notation. Okay, so letter J, how many inches per minute are in 30? Oh, you see that decimal there, so that means we have 2 significant figures. 30 centimeters per second. So 30 with a decimal, so don't forget that, centimeters per 1 second. And we're trying to get to inches per minute. Okay, so I'm going to choose distance first, so I know centimeters is going to be on bottom next, and I'm trying to get to inches. Well, we knew from up top in our other problems that 1 inch equals 2.54 centimeters. Okay, so centimeters cancel out. I'm in inches, which is what it wanted, so I'm done with distance conversion. So now I'm going to do my time. I'm trying to get from seconds to minutes. So I know seconds is going to be on top here, and I can get to minute. So I know 60 seconds are in 1 minute. Okay, seconds cancel out. I'm in minutes now, so now that means I'm done with my steps. All I got to do is my math. So 30 times 60. Divide that by 2.54. Gives me 708.66. Okay, I started off with 1, 2, so I can only have 2 significant figures. So I can have 1, 2, draw my line. That 8 tells me round up. Do not write 71 and be done. 708 does not round to sound at 71. It rounds to 710 inches per minute. Letter K, 4.5 times 10 to the 24th particles. Okay, so we will give you these. You do not need to know it. So start with what you're given. So 4.5 times 10 to the 24th particles. I'm just going to abbreviate it, part. Okay, so I know particles is going to be on bottom next. And if you look up at your conversion factor up here, I know 6.02 times 10 to the 23rd particles equals 1 mole, which is what it's asking for. So units cancel out. I'm in moles, so I'm done with my steps. Now I just got to do my math. So 4.5 times 10 to the 24th divided by 6.02 times 10 to the 23rd. That gives me 7.475, and it goes on and on and on. But I only had 1 2 significant figures to start with, so I can only have 2 in my answer. So 7, 4, draw my line. My answer becomes 7.5 moles. Okay, that is conversion. So let's move on to quick precision versus accuracy. Okay, so remember, precision is how close the values are to each other, not necessarily how accurate you are, and then accuracy is how close you are to a targeted value. So number 9, a group of students determine the density of an unknown liquid, the actual value. So this is my accepted value. So that's what our average should be if we're to be accurate. They obtain the following values. So 1.34, 1.32, 1.36. Describe if they're precise, accurate, both, or neither, or explain why. Okay, so I'm going to start with precision. They are precise because measurements are close to each other. Okay, so precision is how close they are to each other. Okay, so those look pretty dang close to each other. Now, accuracy is if the average of these values is close to the accepted value, then it is accurate. So I could do 1.34 plus 1.32 plus 1.36, divide that by 3, and I get 1.34, which is the accepted value. Okay, so that means it is accurate because average equals accepted value. Now, it doesn't have to exactly equal it. It just has to be close. Okay, so part B, evaluate the accuracy and precision of each of the following thermometers used to measure the temperature of the boiling water. Okay, so the standard temperature of the boiling water is 100 degrees Celsius. So that is my accepted value. So let's look at thermometer number 1, 98.3, 98.5, 98.4, 98.7. Okay, so those are all pretty close to each other. So I would say it is precise. Now let's look at if it's accurate. Okay, so 98.5 degrees Celsius. Okay, and my accepted value is 100. Okay, so that is not next to 100. So you need to be pretty dang close to 100. Okay, and we're talking about temperature. 1.5 degrees Celsius is quite a big jump. So this would be not accurate. Okay, so I'm not going to write why because I just kind of got through explaining it, so that'd take me longer. So thermometer number 2, you can take your time to write why from what I just told you. Thermometer number 2 is, so we look at thermometer number 2, 97.5, 99.7, 96.2, 94.4. They are all over the place. So that is not precise. And let's look at our average. 97.0 is not, it's even further away from 100. So that is not accurate. So thermometer number 2 is not precise, nor is it accurate. Thermometer number 3, 97.5, 102.3, 99.7, 100.9. Sounds like I'm just throwing off a bunch of radio stations. Okay. So if you look at those numbers, they're all over the place. So they are not precise. Okay. Now let's look at the average. So the average is 100.1. That's pretty dang close. So that would be accurate. Thermometer number 4, 99.9, 100.1, 100.0, 99.9. So that is definitely precise because they are very close to each other. Our average is 100 on the dot, so that is accurate. So again, you can write off to the Y. You can explain from what I was talking about. Last thing, measurements. Okay, so measuring, when we come to significant figures, is you have to always go one more decimal place than you can see. So if I look on this first one, letter A, I can see 1, 2, 3. So if I were to write the number 3 centimeters, this would be wrong. I need to go one more decimal place than I can see. So my next decimal place would be the tenths. So if you think this is 3 on the dot, you would put 3.0. That would work. You could put 2.9. That would work. You could put 3.1. That would work. The key to this is I took it one more decimal place than I could see. Okay, so pretty much any of these would actually work. So now let's look at B. So my line, it looks like, so it's somewhere between 4 and 5. We know that. So we know we can see the 4 and 5, so that is our ones. Then we can see all these little tick marks. Those tick marks count as 0.1, so that gives me my 10th place. So if I look close to the line, it looks like it's somewhere in between 4.2 and 4.3. So if I were to write 4.2, I'd be wrong. If I were to write 4.3, I'd be wrong. The reason why you'd be wrong is because I can see the 10th place. Those tick marks is the 10th place. I cannot see the 100th place, so you need to take it one step further. So it looks like it's actually in the middle to me, so I would say it's 4.25 centimeters. That would work. You can put 4.26. That's fine. You can go on and on and on, so 4.24. Okay, to an extent, so you can't say 4.72 and expect to be right. Okay, but I took it to the 100th place now. So I took it a step further. So there are multiple accepted values on this as long as we see that A, you're close, and B, you took it to the 100th place. Letter C, okay, graduated cylinder. You always measure from the bottom of the curve. So if we look at our close-up, we know we're in between 40 and 50. Okay, and then our tick marks actually go up by 1. So that's 41, 42, 43, 44. So it looks like it's pretty much right there on 43. So if you were to tell me 43 milliliters, you'd be wrong. Okay, I can see those ones. I can't see the 10th place in between that. So if you think it's 43 on the dot, put 43.0. That would be correct. If you do not think it's that, you could say it's 42.9. That'd be fine. You could say 43.1. Again, there is room for interpretation on that, but the key thing is I took it one decimal place further than I can see. Okay, and that is it for the review.